Thanks everybody for joining us. This is FinOps Transformation, how Salesforce unleashed comprehensive and agile data models over the last year. My name is George Parker. I'm the Director of FinOps Product Management at Salesforce for internal products. I also oversee capacity product management as well.
I'm Dhanush Devaraj. I'm the lead FinOps Engineer for Salesforce.
And also a special shout out to Will Forrester, who's probably going to watch us on YouTube at some point. He's our Director of Engineering, our close partner in crime, and he helped us put a lot of this content together today. A little bit of background before we talk about the details here. Salesforce has been running in the cloud for a long time. If you know Salesforce, we pretty much started in the cloud. It was private cloud 25 years ago. But first announced in 2020, we made a pivot to public cloud. We call it Hyperforce. It's a cloud-native architecture that empowered all of our customer agility. Customers that had been running for decades in on-premise data centers were able to port their custom applications and integrations to public cloud. And I think as everybody here knows, if you pivot to public cloud, you're going to need to change your FinOps tooling. So that's what we've been doing for the last few years. Dhanush and I specifically are from the Cloud Economics and Capacity Management team. We provide data analysis and forecasting capabilities for Salesforce infrastructure. We're one of many teams focused on availability and infrastructure engineering within the broader Salesforce engineering ecosystem. One of the consistent themes that we've found about our FinOps at scale is that it is a big data engineering problem at the end of the day. This is because of our scale. But for the diehard engineers, you're probably going to notice some standard engineering principles that we required in order to scale throughout this presentation. As we tried to address our FinOps concerns, we applied a lot of things that you're going to be doing in your standard engineering teams already. So this shouldn't be novel and new in some ways for the engineers, but how we apply them to the FinOps problems is what's unique here. In the FinOps context, our broad team includes both FinOps practitioners and cost engineering that builds supporting tooling for showback, cost allocations, budgeting, and a whole bunch more. In the following presentation, we're going to deep dive into some of the specific methodologies that we use to build our data lake, how we evolved our data models, and how we approach quality as a topic. We're also not the only team at Salesforce that cares about FinOps. We have some great finance partners here. They're actually going to go listen to Apple right now. We also have a partner sourcing team who's sitting in the second row here. We couldn't do it without them. Our colleague I just met, Raheel, he's from Slack, part of the Salesforce ecosystem as well. There's a lot of people at Salesforce that care about FinOps, and I think if you've been listening to the keynotes, you know that it takes the whole community, the whole company to think about FinOps as a problem, and I think Salesforce is a good example of that. We also have some service and budget owners from across the business that represent individual service teams. At Salesforce, there's largely two major orbits of FinOps personas. Our team's a little bit in the middle, as is sourcing and finance. We have the folks on one side that drive corporate strategy. This is FinOps, finance, execs, and procurement. And for this team, for this group, our team holds a monthly budget review and tracks weekly KPIs to ensure that we're on track for our budgets, on track for our strategic objectives. And to be successful with this audience, we need to solve for high fidelity and extremely rigorous data quality while accelerating the teams through simple to use executive dashboarding.
And then there are folks that are actually driving the change, which is engineering, product, sustainability, and service owners. For these audience, we focus on building self-service-based tooling. So to be successful here, we focus on having the tooling to be flexible and then providing deeper insights that cater to the nuances of their services. So today we'll share how we applied Agile principles to our FinOps architecture, which ultimately transformed our team from falling behind to innovating over the last 2 years. So back in 2022, a lot of the reporting done to the executives were all in Google Sheets, and it required a lot of manual time to build. Service owners weren't happy with the tools that existed because it wasn't really meeting to the needs. And all the work that we were doing wasn't having any customer impact. So at the beginning of 2023, we went back to the drawing board and proposed a complete greenfield re-architecture. So to make Salesforce FinOps successful, we focused on re-architecting with a few key Agile principles in mind. One, reacting quickly to the changing requirements, continuously reflecting on the progress that we have been doing, continuously collaborating with our customers to drive product engagement and scale, and consistently improving through incremental investments. So with all of these Agile principles within 6 months, we had decommissioned the previous products and rebuilt the products ground up. During the process, we also cleared off majority of the technical debt. And now we began to innovate, and we delivered numerous new FinOps capabilities that were requested over the previous years. Our users and customers were happy, and we had managed to turn around the internal customer sentiment. The business needs still continue to change, but now we are able to deliver with agility, all while upholding that customer trust. So throughout this talk, we'll be sharing some of the key learnings from the transformation.
There were three major factors that were critical to our overall success, and we're going to structure this presentation around those. First was leveraging a unified data lake, and that enabled us to react quickly to change. Second was designing for flexibility to support the actual business needs. And finally, continuously impacting and improving and inspecting our data quality. With that, I'm going to start with the unified data lake, because you can't develop a whole lot of FinOps maturity without a lot of data. And at scale, again, I want to reinforce this is a big data problem that requires big data solutions. We'll pause here, because I know people like to take pictures. This is just an architecture slide. I'm going to pause on it so that you can take that shot. We're going to walk through this slide in a little bit more detail throughout the deck, highlighting a few of these blocks as we talk about them. Our first bottleneck to the team's throughput was that our data was in disparate sources. Prior to 2023, we were accessing and reading from a lot of different data sources. Most of your FinOps capabilities require billing data to be joined with other data sets, things like infrastructure metrics, CPU utilization, logs to show customer usage that you might need for unit economics, and metadata, like team ownership mappings that help you with your governance plans. Every time we needed to onboard a new data set back in 2022, anytime we had a new user request that required us to access a new data, it would take more than a week to develop, deploy, and ingest a new metric. And this created a huge tax on basically every feature request that we had. Anything to do with expanding our existing FinOps capability was at least a week just for the overhead to get the data. So beyond new ingestion, this slowed our resolution. If we had operational impacts, if we had performance or availability challenges, and all that contributed to user frustration with our toolchain.
So to overcome this issue, we made a strategic decision to move from working and operating on a custom on-prem cloud-based platform, custom on-prem platform, to migrate to a Salesforce internal cloud-based unified data lake where the metrics, logs, and metadata were already hosted. So we had to onboard the cloud billing data to the platform, which we did so by configuring cloud-native replication. Cloud-native replication provides a low-maintenance, seamless way to ingest billing data to the data lake. So by co-locating all of these key data sets needed to build the FinOps capability, we could now join the cloud billing data to either metrics, logs, or metadata by simply switching table references. We also removed the need and the operational overhead of maintaining the previous ingestion pipelines needed. So by unifying all of these key data sets in the same data lake, you can bring significant agility to your team. To us, this helped reduce the data ingestion effort of about needing 1 week effort from the team to less than 1 hour. So this helped us develop 3x new FinOps capabilities in a year with exactly the same team size. So we were able to add a new budgeting structure, a self-service-based unit economics, and a workload optimization dashboard. So we also improved the shared cost allocation coverage from 70 to 95%, which represents majority of the Kubernetes cost, and that's also one of the biggest spend drivers. So once we were on the unified data lake, our next focus was on to making the data models flexible.
Thanks, Dhanush, that's right. And I think if you look back at the lesson about unified data lake, if you're running your systems out of multiple different data sources, think about how you might unify them. Once you unify them, you need to start thinking about the flexibility of the data model you're putting them in. As you start defining your unified data lake, you're going to be setting schemas that are going to influence how you access and read data in the future. I'll give you an example from back in 2022 and early 2023. When I switched into the FinOps team last year, and I have a history at other companies of doing FinOps, but was in a different role. At the beginning of 2023, we had really the opposite of a flexible data model, and I really would call it death by spreadsheet. We have at Salesforce tens of thousands of accounts. So just tracking the new accounts created every month meant that it took one person about 3 days every month just to add the new account mappings to our data sources so that way we could do financial reporting on them. It was way too much. The pace of change was literally faster than we could keep up with. New accounts would just be missed in the monthly reporting cycles and have to catch up next month because they just weren't there. We simplified what that looked like on this slide just to show a few pieces of the data. But at the time, we maintained all of this by hand in a spreadsheet that had about 200,000 cells. There's about 20 columns and about 12,000 plus rows. Each row was uniquely indexed by the account number, and it was consistently growing by hundreds of rows every month. In this kind of data source, there were actually only a few pieces of interesting data, and they're shown in the table on the left here. For us, it was something that we call domain. We had the product and the executive to go along with it. It was the exec that footed the bill, the product that it was under, and then it was all, again, uniquely indexed by that account. Much of the rest of the data in the other 16 or so columns was just duplicate, copy and paste over and over again. That in turn made it impossible to tell the difference between an exception and an error. Did somebody accidentally drag a row down, and that's why it's different for this one account? Or is that because this account really is special? For any new entry, it was obviously slow to be updated, and it made it very difficult to extract or grok the budget relationships between these 12, 15,000 different accounts and tell which services belong to which executives without just going through line by line. So think about if you have a data source like this that you could maybe ascribe to the death by spreadsheet, think about how you might remove this anti-pattern. Instead, what we do now, in the last year, we model this structure as a set of key relationships. We distilled it down to 2 key relationships. It's the domain that maps to the product and the product that maps to the executive. This eliminated all of that duplication of data. We actually don't even need that account ID anymore, which used to be our unique field that made us generate all of those rows. We don't need it anymore because the accounts are all tagged with that domain already, and we can now roll that up to product and executive. It's much simpler. This is higher quality. Any exceptions are clearly called out in a separate set of logic, so we ensure that there are no errors in this. It's faster and easier. New entries can be added now on a self-service basis by the FinOps team themselves, and all the downstream tooling reflects the change within about 12 hours. In a lot of cases, when a new account is created, we don't even need to make any edits. Because we're no longer looking at the unique account ID, if the tags are correct, it's automatically processed and it shows up in the billing the next day. And it's a whole lot more explainable. The whole thing is about 200 simple lines of configuration that we frequently share with budget owners and executives that want to understand what they're being charged with. I'll literally get a Slack message that says, hey, this account showed up on my list the other day. I don't know where this came from. And I can just respond, oh, here's the mapping for the whole entire fleet. It'll take you 5 minutes to read. Just go skim that. And I usually get responses like, wow, I was always really looking for a way to see the overview like that. Thank you. This transition to a config-driven, or what Salesforce oftentimes will call a clicks, not code approach, means that the FinOps practitioners are able to self-service a whole lot more than they were in the past. Last year alone, our FinOps team made over 500 plus configuration updates in Git itself, updating the budget reporting on their own. We manage all of this currently as YAML on Git, an approach that some of you might already be taking as well. I like the Git workflow. I think we all do. It enables audits, CI workflows, and tracking, and so that's really helpful for us. We get peer reviews when these changes are made. We have a reference to who made the change and why. If you can replace some of your tabular anti-pattern, some of that death by spreadsheet with this kind of relationship structure, it is simpler, it is faster, and it is more accurate, and it's even better when it's self-service and accessible to all your non-technical users. That example works great for account-level internal billing, but what about resource-level tagging? Some of you might be guilty of this. My last company was insane tagging requirements, right? Like 12 tags per resource, label it with every known piece of metadata you could possibly need. That's the way my last employer did it, and I'm happy to say we don't do that here at Salesforce. The problem with that approach is several-fold. It is relatively impossible to add or update tags retroactively. You're going to have human error. We never really, at my last company, could get FinOps coverage past 95%, mostly due to that human error component. To solve this at Salesforce, we really only care about one tag now. The one tag that we care about is enforced on our corporate objectives, it's reported on globally, and it's enforced in CI pipelines. We add OPA policies when gaps emerge, and we make sure that everybody is using this service tag. That tag needs to be very granular. It ties back to the individual microservices being deployed. Pretty much everything else is going to be derived, and it's shown here in yellow, from a metadata API that we call all of the other references from. Using the service tag and then referencing it against the metadata API, we can map it back to teams, we can map it back to managers, we can map it back to engineering orgs. And thanks to our unified data lake, we can further join it to that account data so we know all the details from that interface, adding in context about environments, budgets, and products. And as a result, we've improved our reporting coverage from 95% to about 99%. We can also now backfill, which is hugely critical for us, providing the capability to retroactively associate new metadata with existing resources. This gives us tremendous flexibility to make a change in the middle of the fiscal year while still offering consistent fiscal year reporting without weird spikes or jump cuts in our data. And we can even do A/B testing, which we use to develop next year's framework while still reporting last year's budgets.
So a challenge we ran into when developing new FinOps capabilities at Salesforce was the sheer number of services that existed at Salesforce. So there are about 1,000 plus services, and a central FinOps team trying to build a new FinOps capability for every service which has varying implementation needs and methodology wasn't a scalable approach. So what we focused on building is externalizing the implementation details and providing generic processing capabilities. So one example I would like to talk about is unit economics, where this was really helpful. At Salesforce, we care a lot about unit economics. Whether it's customer usage due to internal or external demand, it can drive material cost swing to services. Now, service owners can't control the demand, but what they can focus on is whether they're getting consistently efficient with the varying scale needs. And unit economics is one such metric that helps with it. Now, to onboard a unit economics metric, a service owner needs to write down a YAML-based configuration. YAML provides a simple interface even for non-technical users to write down configurations. So the YAML configuration is then submitted to the onboarding interface. In our case, this is Git. As George just said, it provides like easy version control and audit tracking. So, and then there are daily pipelines which ingest all the configurations from the Git process and publish the data to the live Tableau dashboards. Now, customers can look up their newly processed data on the dashboards, and they can track metrics even time over time based on the backfill needs. Now, this has enabled onboarding service owners to either a unit economic capability or a cost allocation framework and publish data to our live dashboards in less than a day with almost zero engineering effort to our team. Now, diving a little more into the onboarding interface and the configuration itself, so we capture as much key metadata as possible as part of the interface. There are about 4 different areas. One, data governance. That is who owns the data and what is the classification of the data set, whether it's internal or restricted and publicly allowed, so on. And then retention, that is how long users want to store the data. It could be a number of days, whether it's 6 months, 12 months, 13 months, so on. And then documentation. So documentation field highlights the key input and the output metric descriptions. So you can see based on this information how we can generate an automated data catalog from all the configurations. Now, and then there's the 4th part, that is the key part, which is the metric calculation itself. In our case, this is through a SQL query. So the SQL query allows the parameters to be filled in during runtime, and the pipelines execute those SQL queries. An example query is joining yesterday's infrastructure cost with yesterday's infrastructure customer usage to calculate the unit metric.
Previously, our primary data model consisted of a single cost output that we called total cost. This was our approach in 2022. It represented the budget impact of a given service, inclusive of discounts, fees, and credits. We ran into limitations with this approach as it created a monolithic cost number that lacked any detail needed for further analysis. Just one example for us of how this penalized our efforts, as we began to receive a large amount of one-time credits on random accounts, it created anomalies in our budget run rates for all those services. Execs wanted all the one-time anomalies to be hidden. They wanted to see consistent, predictable numbers. They didn't want the jump cuts in the data. So they wanted us to exclude all those credits from the total cost to stabilize the trend. Unfortunately, the limits of that older, less agile data approach limited us in our ability to execute that change quickly. So excluding credits meant that we needed to create separate fields and migrate every stage of our processing pipelines to support these new fields, then backfill all of that data. And it took us over a month to do that, all while the engineering leaders were fundamentally confused or misled about what their budget impacts were.
So to overcome this pain, we redesigned our data models for end-to-end agility with the goal of being able to react to those changing requirements, which George quoted an example with the goal of reacting to them in less than 1 week. So to achieve this target, we introduced a field called charge types. So charge types are nothing but the cost categories which previously formed the composition of total cost. Now, instead of storing a single output called total cost, we store cost by all of these array of charge types, which was useful to Salesforce. Some of the examples are the usage charges, commitment plan discounts, credits, and so on. Now we define total cost as a combination of these charge types. You can see how we could include or exclude credits in less than a day and publish to our customer-facing dashboards based on the business requirement. So this also prevents us having schema migrations when we are adding new charts types, because now we are adding them as rows instead of as columns. So this prevents a lot of effort needed to migrate all of our ETL steps. So beyond the data model, so beyond just the agility, the data modeling helped us provide deeper insights which were previously not possible. An example use case is, for example, an engineer wanting to track a specific architectural optimization without the added noise of discounts and credits could do so by just looking up the usage charge and the cost, by just looking up the usage charge and the cost associated with it. So they could just focus on one metric and then see how their optimization was going. Once we had the unified data lake and then we designed our data models for flexibility, our next focus was on how we can continuously improve the data quality. That is the data that we were publishing to our customers.
The last major piece of this presentation is around data quality. Data is the foundation of FinOps, and if that data is not accurate or not available, the business will run the risk of making decisions on incorrect data, and it will break trust with your users. They won't act on the insights that the FinOps team is providing, and it'll put your organizational goals at risk. We want to encourage you to build your brand around data competency and maintaining trust in the data. You should continuously prioritize inspecting and improving that data quality. I'm going to highlight a couple things, external artifacts that you might want to reference. There's a really good white paper on the FinOps site. It's called Building and Maintaining Healthy Working Relationships for FinOps Practitioners. And it talks about the deep importance of trust for FinOps teams, and we couldn't agree more. Another reference in the marketing world, there's a concept called brand personality. I'm not a big marketing person, but back in the 90s, this marketing industry legend guy, David Aker, wrote a framework that said all brands basically subscribe to one of a few specific personalities. They're listed here: sincerity, excitement, competence, sophistication, and ruggedness. We use this lens to talk with our team and reinforce the importance of what we call data competence. We're not trying to build the most rugged FinOps team. We're not trying to build the most sophisticated or sincere team, but we want to be really competent at our data. We've talked about the reasons why. Incorrect data creates risk, it hurts trust, creates operational risk around making bad decisions, it creates trust issues that prevent cultural adoption, and it compromises your accountability structures and governance at your company. To build your brand around data competency and maintaining trust in the data, that's the importance of prioritizing the continuous inspection and adaptation of your data quality commitments.
So to achieve data quality, first we created a framework that allows our pipelines to run automated data quality checks. So the newly processed data is published to the customers only if all of the data quality checks pass. If any of them fail, there is an automated alert sent to our engineer on call for immediate triaging and resolution. So once we had the framework in place, we brainstormed and added data quality rules throughout our software development lifecycle. So before releasing a product, we incorporate data quality as a design review component. As part of the PR reviews, we make sure that every change that is being pushed has the necessary data quality check associated with it. And in case of outages and root cause analysis investigations, we brainstorm how a future data quality check can prevent such scenario. So overall, the data quality framework and the rules have helped us prevent issues in numerous scenarios and help maintain customer trust. A notable one from a recent time is when a few $1 million discrepancy in a specific charge type calculation was automatically caught, and the team was able to triage and resolve, and this was due to a billing column definition change. The incident was prevented from being pushed to the customer. So once we had the data quality framework, we have a way to measure and report on the quality of the data. It was now important to call our shots and follow through. To us, this means setting up SLOs and making sure that we follow the SLOs by tracking them and optimizing for the SLOs. We track our SLOs across 3 key metrics. One, availability. We want all of our data to land in less than 24 hours. And then accuracy. Between 2 sources of data that we are comparing, we want them to match up to 99.9%. And for latency, we want the dashboards to load in less than 5 seconds.
SLOs, in our case, is service level objectives, and we distinguish that from service level agreements. These are our targets, this is what we measure, this is what we manage. We meet regularly to look at those service level objectives and review the key business outcomes. One of the things that is really important for us to look at is our support ticket load. How many incidents occurred, how many users were impacted, what are they asking for? Are they asking for enablement, or are they asking about issues or feature enhancements? We also look heavily at monthly active users, which reflects how people are engaging with our products. We currently have about 1,200 plus internal monthly active users using our FinOps tools. Beyond just measuring and tracking these numbers, it's also important to action on the improvements that you identify. This could mean things like prioritizing actions from a recent root cause analysis. It could also mean improving developer productivity, having a conversation between engineering and product to say, we really need to do this so that next release we can go faster. And another piece of prioritizing engineering changes is actually just communicating the impact to our users and following up on the RCAs that builds the trust that our team is being diligent and competent with our data. By creating this positive feedback loop, we improve the availability of our tools from about 81% to 98% within the last year. We believe this brand of data competency helped drive the FinOps cultural adoption, leading to the monthly active user improvements on our flagship product alone from 200 to 700 monthly users. Last piece of that strategy for quality is also our UI. With our old architecture, it was a custom web app. We had a very limited basic Explorer capability. It was relatively expensive and slow to add new features and functionality. By switching to a BI tool, we had tremendous velocity gains by switching. Being able to just drag and drop our data was itself a huge boon, but we also gained a whole host of other features that we would have had to build ourselves. Things like alerting and subscriptions. I can use those to track missing data. Sharing capabilities that help me quickly troubleshoot a customer's issue because they can send me a URL directly to the view that they're looking at, and I can do the same. While engineers are troubleshooting production issues, the engineering manager or product manager can actually go in and add a data warning to the UI so any new customer who looks at that dashboard is alerted that the data here may be faulty and we're investigating. This approach works well for us. We're a big fan of Tableau. Some of you might be using other tools. That's totally cool. We just want to encourage you to fall in love with your BI tool and see if you can get velocity gains out of it. A lot of you might also use your cloud provider's native Explorer capability. That's totally cool. I know I was happy with it at a previous company. But if you do have access to that BI tool, I encourage you to take a look. We use it to build other capabilities beyond just exploration, which is what we offered when we were a custom web app. Because of the speed gains that we got from developing on a BI tool, we now have self-service unit cost dashboards, we have budget reporting, and there's a whole lot of other stuff that was being done in spreadsheets and slide decks that can now move. Our flagship product, not shown here, is our internal Hyperforce Cost Explorer. I told you about Hyperforce at the beginning of this. We have a Cost Explorer for that. Again, about 750 users every month. We have an infrastructure budget dashboard that's used by all the engineering EVPs and their budget and operations teams to track cloud cost performance. We also now provide a dashboard where internal customers can go look up all of their onboarded unit economics. With the ability to slice and dice the metrics by some of the key dimensions, they don't have to work on building a UI or any of the reporting. All they really have to do is set up that YAML file Dhanush showed us, set their query, tell us what their unit metric is. We already have all that cost data. It's very fast. So about 6 service teams onboarded in the last 2 months, providing service teams the ability to build their own unit economics and just leverage the framework that we built to do it faster. We also keep, because of the power of our BI tool, a staging version of all of our dashboards. If we're making changes, it's very easy for us to not have to go stand up another custom web app, but simply to have another copy of our dashboard where we play with the production and staging data differently. We're really excited to continue the journey this year. With the methods outlined here, we accomplished a whole bunch of objective, quantifiable KPI things. I think the real value has been the trust that we've built, some of the quality that we've built, the way it's changed our organization. Seeing that many more people accessing and loving these tools. I've had people from our company come up to me during this conference and say, hey, I heard about that thing that you guys built. Like, that's super awesome. I'm starting to use it. I might build a version of it myself. So that kind of traction doesn't fit on a KPI slide neatly, but that's really the power of what we did in the last year. And I hope that some of the learnings that we've had, some of the methodologies we've taken might help influence how you're building your tools at your company. It'll free up space for more innovation, more features, and ultimately more user satisfaction and FinOps adoption. We'll close before we go to Q&A. Again, excited to continue the journey. We're building new product features. We're adding new levels of budget hierarchy, going from more granular down into the org. Shout out to Julia Harvey and Ursula Levesque from Nationwide. If anybody knows them, they did a great presentation last year at FinOps X on the coin score. We totally copied that. Plagiarism is the sincerest form of flattery. It's providing us more savings opportunities internally. We all have all eyes on Focus. I'm personally a member of the Focus working group and actively participating there. We're super excited how that can automate our ETL processing for other vendors. We're implementing new business process changes, adding new financial metrics, improving our margin analysis, improving our automation. We're looking at layering in some AI use cases. For us, that means right now building kind of some SQL capabilities. We have a lot of people who ask to be able to query the data. We can very quickly use Gen AI to help us with that. And we're just excited to come back to FinOps X for all the reasons that all of you already know. This kind of community, this kind of sharing is really why we're here. We'll pause here and open it up for Q&A for the rest of the time.
Thank you both. And sticking with the theme of the conference, I will not be running to you with the microphone, but I will lightly jog. Hands up in the air. Got one right here. My light jog.
It sounds like you have internal customers who are reading directly from the data lake, building their own reports, building their own dashboards, whatever it is that their specific needs are. How do you handle the changing data schema with potentially a large number of internal customers who may be impacted when, say, all of a sudden your schema aligns to Focus, for instance?
It's a good question. And by the way, that's Carl from Walmart. He's an active member of the Focus group too. Shout out to Carl, brilliant mind. We mostly have been able to keep it relatively stable. We have added a few other tables over the last year. We're having a discussion now as we start working through multiple layers of cost allocation. It's not just distributing our Kubernetes spend, it's distributing the tenant charges on Kubernetes. So now we're having to peel the onion with allocations, and that may drive some new columns. We were talking about that on Monday at the office. We've mostly been able to kind of follow an evolutionary schema approach where we're just adding a column. We're not really having to hard cut people over yet. It's one of the reasons why I think going back to the Focus discussions we've had around versioning the API, we want to be really, really thorough if we're going to make any kind of breaking changes. I think all of the major cloud providers are pretty conscious of that stuff too, so we just don't really want to go through and like rip a column out all of a sudden. We've talked about like adding like a new column and just calling it like beta column name instead of the current column name. So we've been working through that. I think it's kind of a case by case, but mostly I don't think we've had any real breaking changes with our tables. We've just added some more. Dhanush?
Yeah, pretty much the same. We have tried to make it backward compatible so far, and we have been successful. Some of the other ways like we are thinking to handle them is like having V1 and V2 schemas, where like customers will have to migrate over to a new schema. Although sometimes we try to abstract through views instead of like directly exposing the table, so we can hide some of the intricacies for our customers. But yeah, we haven't run into a real breaking change scenario yet.
I question on the pricing showback. Like if we have teams trying to do forecast and then the showback logic, are you guys using like actual prices from like an OS where it's like on demand and then we buy a bunch of flex CUDs because their resource CUDs expired? So they didn't do any quantity changes, but they saw a big dollar difference and now it's throwing us off. So how do you guys solve for actual or like a rolling 90-day blended average? Like how are you guys attacking that?
That's a good question, and that's Brent. Anybody else who asks a question, I encourage you to say your name and what company you're with, just I'd love to meet the community here. I had dinner with Brent last night. It was nice to sit across the table from him. Forecasting is a little bit different topic than we were covering today. It's a really good question, though. We're still working through some of the details on forecasting. We're right now in more of a naive trend-based forecasting and working to layer the driver-based stuff on there. Most of what we're doing today is either with the raw usage cost or with the total kind of aggregated cost. There's a huge value in being able to separate out and see what like kind of the engineering impact is and forecasting with that kind of raw usage cost. But at the end of the day, it is going to come down to what's the net. We do separate credits out, which helps tremendously. We've kind of pulled that out, and so to a large extent, we're consistent with our pricing agreements and everything like that. But without going into too much more detail about all the nuances of pricing rates and stuff like that, I think that's generally we look at it from a total cost perspective, absent or sans the credit.
Two questions. Number one is you talked about, you have re-architected the whole tagging nightmare and saying just using 2 tags. Can you give me a little more detail on that service owner tag for a containerized environment? That's my first question.
Sure. Dhanush, you want to take that one?
Yeah. Services are deployed in pods for Kubernetes and volumes requests are on. It's more tied to the architecture, but we are able to tag even at the level of the deployments pod, for example, or in Kubernetes for EBS storage, there's persistent volume claims. So either claims or persistent volumes themselves are tagged. So we are able to retrieve those, and then when we allocate, we are able to provide a unified view of a service cost, whether a service is running within a pod or it runs in its own instances. So we are able to unify that. But tagging has to go beyond just the resource itself, like sometimes like the pod and anything that's deployable.
Just to follow up, does it take any CPU or memory metric? Because at pod level, but then it comes back to the container.
Yeah, so we use the pod level requests and use CPU cores both to determine the cost show back. Again, it's a broader discussion, but we use a couple of metrics to determine what are the costs of each service is running within a Kubernetes cluster.
I encourage you to stick around and ask Dhanush 10 more questions about that. He can go deeper on this topic, so if you want to know more, he's the guy. I'll also add that we have our own metadata API that helps us. So you mentioned service owner, and I would distinguish that from service name. We actually tag with a service name. Sometimes it's in the pod label, sometimes it's in a resource tag, but we use that service name as kind of that unique index. And then we use a metadata API to tie that to specific service owners, teams, and then we actually can roll that up our org chart and say, okay, that goes to that manager, which goes to that VP, which goes to that product, et cetera. So we have another API that we also leverage here.
And another question I have is on that charge type that you introduced. How do you show the amortized cost?
Can you give an example? Like,
I can take that one. To a large extent, we're not looking at the amortized charges. We've kind of mostly look at that from the monthly bill perspective, so we're not really getting too much into the amortized piece. We're mostly looking at real bill impact. We can extract that out, and if we don't want to look at real bill impact and we want to look at engineering impact, that's where we look at the raw usage cost. We're mostly not doing the amortized piece right now.
Yep, here I come.
I'm curious. I enjoyed the presentation. It was awesome. Actually, it really was. I know him. That's why I'm not just like praising him. I am curious, though. How do you deal with shared costs and give visibility into that for owners?
That's a good question, Ben. Thank you. I appreciate that. Ben Hartwell from Splunk, everybody. Great person to talk to as well. We are in the middle of implementing a self-service allocation interface. We're probably, I would say, about on like the 4th or 5th allocation, and we're getting to the point where it's largely self-service. The first big one that we had to solve was Kubernetes. And I'm actually super excited about the Fission or SCAD feature from AWS. They're actually starting to be able to do allocations. SCAD stands for Shared Cost Allocation Data. It's breaking apart your EKS charges in the bill itself. They already support this for ECS. It's coming out now for EKS. There's a PM here from AWS who can talk more about that. So that's probably the first one. If you're thinking about allocations at your company, you're probably thinking about Kubernetes first. We did. So we solved the Kubernetes piece on our own. We may switch to AWS's solution on this because I like taking stuff from them instead of having to build and maintain it myself. As we got through that one, there was other obvious cases where we had shared costs that we needed to break up. Some examples are our VPCs. Those are shared network resources. Our ODCRs are actually shared across teams. We need to solve for that. We have other networking services I won't get into the details of, but we have a bunch of networking and shared resources across the board where tagging with the individual service name doesn't really make sense because there's a lot of services all sharing one resource. We first took the approach of working directly with the team, doing all the number crunching, and again, this is your guy, so you want to talk deeper, talk to Dhanush. We look at like the system utilization and take that cost and divide it by the system utilization and start attributing that out to the different service owners that are sharing that resource. There's a bunch of different ways to do that. You can look at it from a flat perspective. You can divide it by system resource utilization. You can come up with weighted averages based on P&L. Like there's a bunch of ways to do that. Be careful here because especially when you get into chargeback, we're really focused on the showback of this right now. Our budget's done a little bit differently, but we do a lot of this in the context of showback, not chargeback. When you get into chargeback, you're actually creating some serious business incentives for different pieces of your org. If you start, I was talking to Udam about this earlier, and like if you start taking, a single large monolith, existing, stable, mature product, sharing resources with some startup brand new projects, and then try to do like a flat bill across those, you could put those smaller products out of business essentially because the overweight of the cost on them is just too burdensome. And meanwhile, if it's a shared service that you're trying to drive adoption internally, like let's say you're trying to use Vault, and all of a sudden there's this like $100,000 bill that service is going to get for enabling Vault. They're going to go, wait a second, maybe I want to build a smaller solution, and that actually defeats your corporate objective. So you have to be careful when you get into chargeback for this. Again, we've implemented this a couple times over and over again, and we've been pushing towards making this a self-service interface because our team is not staffed to go learn the details of VPCs and get into the weeds on like how many bits you should charge and should you charge for the IOPS over the storage itself. We're not staffed really to do that. That should come from the team that's managing that resource. And so we tried to push that to be a self-service discussion and make that an interface that they're able to feed to us. I think we're also at the point now where we're starting to give that to our central architecture team and say, hey, this has huge impacts to the business when we divide these costs this way. So let's have the central architecture team tell us if this is a ratified allocation strategy, and then we'll go implement it. We have no problem doing the implementation, but there's a little bit of alignment and corporate incentive there that we have to work through. And then the next wrinkle in that, which we're currently working on solving, and again, we were sitting down on Monday whiteboarding this, we're getting into the state where we have allocations within allocations. We have tenants inside our Kubernetes that need to also do their level of allocation. And so that's actually driving some discussions that Carl raised about like the backwards compatibility of our schema, because now we think we do actually probably need a new column. And so that's driving some conversations. So it's a multi-layer approach. Ben, does that answer your question?
3 minutes remain. Any final burning questions? All right, another round of applause.
Thanks for watching. Check out more FinOps X 2024 content on our YouTube channel on the 2024 playlist. Support our channel by liking, subscribing, clicking the notification bell, and by leaving comments and questions for our speakers. We appreciate your support.